All right, example 9. So this is another center of mass problem, but this time we're dealing with an area. So we're asked to find the center of mass of a right triangle. So we have a two-dimensional problem. So we're going to assume uniform mass per unit area. Here's our right triangle outlined in blue. A, B, and D are the external dimensions of the triangle. X is the distance along the x-axis from the origin to wherever you're talking about, wherever your infinitesimal little strip that we're considering in the integral is. Y is the height of that strip. Okay, so x, dx, and y change as we integrate. A, B, and C are constants. Now remember, we're always, our go-to equation for a continuous system like this is the center of mass is 1 over the total mass, the integral of x dm. And our charge is often to find what is dm. So here, an element of mass is the total mass of the triangle times the total, divided by the total area of the triangle, times the area of the little strip under consideration. Now the area of that little strip changes, right? It increases as you go from left to right. So let's work on an expression for that. So dm, it's going to equals the total mass over the total area of the triangle, which is 1/2 the base times the height. Right? The base was A, height was B, times the area of that strip, y dx. Okay, the strip is outlined in red, has a height of y, which is going to change as you go along the x-axis, always has a width dx. Okay, so take that next step. 2m over ab y dx. Okay, now note that these are all constants. Okay, so the x-coordinate of the center of mass, going back to this equation, 1 over the total mass, the integral of x dm. All right, so 1 over total mass, the integral from 0 to a, right, because we're integrating from here right across there. Make that x. Now we're plugging in our expression for dm. So that's 2m over ab y dx. And work that a little bit, take out the constants. 2 over ab is the integral from 0 to a. Oh, the m's go out, by the way. 0 to a of x, y, dx. Now, this is a little awkward because we have a y here, but we know that y is a function of x, so we can't do this integration until we get y in terms of x. So we're going to use similar triangles. By similar triangles, the little triangle is as the big triangle, right? The little triangle, y is to x as b is to a. They're going to be in the same proportion, right? So that gives us an expression for y. That wasn't too bad. B over a times x. All right, so this is going to go into here, and it's going to take us the next step along here. XCM equals, now we have 2 over AB, just like we had up above, integrating from 0 to A. Now x Now for y, we're substituting this. Okay, that's where that came from. And then the dx. So, what have we got here? 2 over a squared, right? Because the b's go away, they're constants, and the a ends up getting squared. 0 to a x squared dx. And when we do that integral, we get 2 over a squared, x cubed over 3, evaluated from 0 to a. 0 is just going to give us 0 result. So this is going to equal 2/3 a. So that's the result in the x direction. Now you need to find the center of mass in the y direction so that you can locate it. So you just, I'm going to leave that to you to repeat and find that. And here's the y value of the center of mass. The y value of the center of mass is 1/3 b.